I'm going to talk about the Mandelbrot set. The Mandelbrot set is a fractal discovered by Benoit B. Mandelbrot. It is generated with this recursive formula on the complex plane. What does that mean? Let's start from the basics. Every number has a square root, right? Wrong! -1 has no real square root, because a negative number squared is always positive. Its square root must be imaginary. The square root of -1 is an imaginary number we will call I. Any number involving I is known as a complex number. The neat thing about I is that when you square it, it equals -1. This can make some interesting things in mathematics possible. This is the complex plane. Instead of an x and y axis, we have a real and imaginary axis. Cool! For example, this complex number would be here on the plane. 1.5 units left and 1 unit up. Mega cool! Oh, but it gets cooler. Remember our recursive formula from before? The c here represents a complex number. Let's use our good old friend, -1.5 plus I. Z sub 0 equals 0. Z sub 1 equals 0 squared plus c, which is our number. Z sub 2 equals that squared plus our number. That's -0.25 minus 2i. Z sub 3 equals that squared plus our number, which equals -5.4375 plus 2i. When we do this for a while, we can see that the number keeps growing and growing. It's therefore not in the Mandelbrot set. So we'll color it, a shade of blue. Let's try the equation with the number -1. Z sub 1 equals 0 squared minus 1. Z sub 2 equals -1 squared minus 1. Z sub 3 equals 0 squared minus 1. Z sub 4 equals -1 squared minus... Hey, wait a minute, we're going in a loop. That means -1 is a part of the Mandelbrot set. We'll color that point black. Now, what if we did this with every point in the complex plane, color-coding each point based on how fast the number grows? If the number goes in a loop, we color it black. Doing that, we get this shape.
Crazy!
The edges are kind of rough, though. Let's zoom in and see what this thing really looks like. We get this shape.
Crazy!
The edges are kind of rough, though. Let's zoom in and see what this thing really looks like. Wow! Look at that structure! Check it out. We zoom in here and find some 5-fold symmetry. And next to it, 7-fold symmetry. Then 9-fold symmetry. Then 11, then 13. And if we go way far down, each arm curves in on itself, making an incredible, intricate structure. Within the Mandelbrot set, we can find a near-perfect copy of the entire thing. And look, here's another. But it's a little crooked. No one designed this mathematical creature. The order, structure, and beauty we find is simply embedded in reality. In this image, I see God. We live in a world of which beauty is an inherent, inseparable part. Think for a second. If no one created this image, how could it be so beautiful? How could it be that way? It just is. Sometimes there is no reason why.